Hello everybody, it's second recording today, Saturday. Yeah, we gotta get to that dot product and trigonometry, okay? Because last time we didn't have enough time. All right, so we get to it. But before that, let's talk some more about this. Yeah, we kind of ran out of time last time and earlier today, right? Saturday. Um, yeah, I had to go to a meeting. That's why I kind of dressed up like this. But so yeah, when I was a computer programmer, my bosses they programmed the law, labor law, so that to help out this HR, human resources people. Okay, so a fantastic program. We had like millions, millions, like 3 million. It's like 1% of population in the United States. 7 people. Okay, we managed like millions of people's human resources record. Okay, so 7 people. Very impressive. Okay, and so they programmed this labor law, the federal and state statutes into the program. Okay, and then one of the biggest client of ours is household name company. Okay, I'm not gonna tell you which one. Yeah, they have in-house lawyers, and they came to us and said, I think you're programmers, and I think your interpretation of law is wrong. So you need to reprogram. And my bosses they said, well, you are our clients, so they resisted at first because according to their interpretation, our computer programmers' interpretation, yeah, part time you get paid half than full time. Okay, but these lawyers, in-house lawyers, and other lawyers even, okay, like they said no, 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 part time, full time, they should get the same pay because it's unconstitutional, it's discrimination. And that interpretation, so basically they're saying, oh, whatever, right? So, and I was studying for LSAT to go to law school back then. Okay, I didn't even put my first foot at the door of law school yet because I didn't even take the LSAT yet. So I looked into the law, and I think my bosses, computer programmers, I think they're more correct than those lawyers who have like decades of experiences as a lawyers. I still thought, yeah, my computer programmer bosses are more correct in this interpretation of the law than those lawyers who went to law school, passed the bar exams, who worked as lawyers for decades. Okay, so David versus Goliath. Okay, yeah, we are just humble programmers. We are small, right? And we are not lawyers. But those big lawyers, okay, yeah, you went to law school, you went to whatever, passed the bar exam, you have decades of experience as lawyers, but we believe that their interpretation is inherently unfair because, well, part-time worker 20 hours per week, that's all they work. Full-time worker 40 hours a week. If we give them the same money, let's say $100 a week, then part-time $100 per 20 hours, $5 per hour. Full-time, same $100, but you're working 40 hours, so what? Dollar 2.5 dollars per hour. $2.5 per hour. Right? So now you are discriminating against full-time employee by paying the same money to full-time and part-time. Now you are making this full-time worker making half the money per hour basis. You know, lawyers, they don't know mathematics really. Not many lawyers are good at mathematics or numbers. They just, oh, it's discrimination. Part-time worker, full-time worker, give them the same money. And I looked at the statute, and I think there was a wrong interpretation of the law. I think the statute made by United States Congress elected officials, I believe they made the right law. They cannot possibly be this stupid. No. I believe the law is just and correct. So, but my bosses, they got pushed by these big clients because they're paying us. They are our bosses. So they wanted to kind of go along with this in-house lawyers, and but I was like, it's just wrong. These lawyers trying to bully us, our humble programmers. I just didn't feel like, and my bosses, they told me, yeah, why don't you call the Department of Law, in the Washington D.C. and just see what they have to say, our interpretation versus their interpretation, which is correct. Yeah, so I called the Department of Law, and they said our interpretation is correct. Okay, none of us were lawyers, and our interpretation of the law was more correct than their interpretation of law, the lawyers. Okay, so yeah, so I didn't have to reprogram. Okay. Okay, some episode that I want to share with you. Okay, and you need to know mathematics. Okay, don't be like those lawyers. That's why I'm educating you. We spend a lot of time doing mathematics, right? You need to know mathematics. No matter what you will do in your future, yeah, it's gonna help you, okay? Alright, I don't wanna drink because I drank too much earlier at home, and now I don't wanna drink. Okay, so I can drink this diet soda, 0 calorie, 0 sugar, whatever. Oh boy. Oh, so good, so good, so freaking good. All right, so trigonometry is easy, okay? You have right angle, okay? Right angle. Well, we're gonna draw this. We'll do it in XY axis, okay? XY, okay? And you have this right triangle, okay? Perpendicular triangle, all right? Let's say, for the sake of ease, the hypotenuse of this triangle is 1 in length. Now, the question is, let's say this is 45-degree angle. What would be length of this guy? That's the question. Okay, so that's will be our starting point of this trigonometry. Okay, so it could be a 45-degree angle. Okay, well, for now it is. Okay, and because 45-degree angle, we'll do some geometry too. Okay, a lot to catch up. You have 90-degree angle, right? Now, what would be this angle? Because 3 angles of a triangle, if we add them up, it becomes 180 degrees. So it will be 45 degree, okay? Okay. in geometry, Euclidean geometry. Yeah, if two angles are the same, then the adjacent uh, line of those two will have equal length. Okay, same length. Uh, do you call it like isosceles or something? Triangle with the same size, same size of sides, two sides. Yeah, isosceles or something, right? Okay, so what we the of course now we have x, y, right? And x is equal to y, right? And Pythagorean theorem, right? X squared plus y squared is equal to 1 squared, because it's right angle, right? A squared plus b squared equals c squared. Okay, so let's solve this equation. Okay, you have x squared is equal to 1 over 2, right? So and square goes the other way, then you have 1 over square root 2. Okay, yeah, so that's x and also y. Okay, so in trigonometry we have cosine, sine, and tangent. Okay, so cosine is so easy. Okay, cosine is you have angle, right angle. Let's say you have A, B, C. Okay, and you have this angle theta. All right. Cosine theta is nothing but ratio of A over C in this triangle. Okay, can you can you see all this? I'm sorry. So cosine, okay, like C, cosine. C goes down and A goes up, okay? Just like this. C first, then A second, alright? Cosine. Now, sine theta, equal to, just like, you write this cursive letter S, okay? So C goes down just like usual. Now you have B. Tangent theta. It's so easy, okay? It's just ratio. Tangent goes like this. Woo! T. Okay? A goes down, B goes up. Alright? That's all it is. Just ratio between this different sides of this perpendicular triangle, this right triangle, okay? That's all it is. Okay? And you have this one as a hypotenuse, right? And you can just draw this circle, okay? Now we have one is the radius, okay? So now what is interesting is this. You have this angle theta, okay? Now cosine theta, whatever angle that is always x. Why? Because it's x over 1, which is x. Sine theta is always equal to y. Okay? Why? Why? Because y over 1, always y, right? Okay. we are running out of space, so we're gonna erase all this and draw it again. Okay, so that's trigonometry. Okay, now we'll do some vector linear algebra. Okay, we are doing a lot of stuff here. We are doing geometry, trigonometry, linear algebra, Cartesian geometry, algebraic geometry. Oh my goodness. Okay. But mathematics is important because those lawyers, they didn't know mathematics, so that's why they screwed up. We, programmers, we know mathematics. That's why we had to correct them, okay? And we did. Okay. So vector calculus, vector algebra. Okay, so let's say this is A, vector A, and this is vector B. What is A, vector A plus vector B? Well, we call it C. What is C? What does it look like? It looks like this, okay? That's vector summation, right? Yeah, that's what it is. Okay, now, if you go the other way, C, vector C can be analyzed into these two vectors. Okay, what is C? A plus B. We are dividing C into two components, okay? So, we have to erase again. It's kind of pretty picture, but we'll have to erase again because we're gonna write a lot. We go back to Cartesian coordinate, okay? So, just like this, X, Y. I'm writing with my right hand, left hand, so I'm giving some rest to my right hand because it's hurting a little bit. So, let's say you have vector that looks like this, C. Vector C. Now, we are analyzing this vector C into two components. X, vector X, and vector Y. Vector X looked like this. Vector Y looked like this. X plus Y is equal to C. Okay? Yeah. Well, vector X, what is it? Let's say this, give it some number, 5. No. Let's give it 3 or 4. 4. 4 comma 0. What is vector Y? 3. So 0, comma 3. What if we add them together? You get C is equal to 4, comma 3. That's the vector C, okay? Are you following? Okay. 4, comma 3. That's C, this dot. And that's also vector C. Okay? We are just adding these two vectors together. 4 plus 0, 4. 0 plus 3, 3. Okay? And if you are good at mathematics, you automatically know what's the length of this hypotenuse? 5. Okay. It's this the Pythagorean triple, okay? 3 squared, 9. 4 squared, 16. 5 squared, 25. Okay, so yeah. There are several of this, okay? Pythagorean triple. This, there's this hissing from the soda pop, 0 calorie. Let me close this very tightly so that it doesn't make any noise. Alright. Okay. Now, you got this? I'm gonna erase it, alright? Now we're gonna do some dot product. Okay, we'll jump right into it. Okay, so what is a dot product? Well, before that, let's talk about projection. All right. Still, we are doing linear algebra. Okay, it's projection. So you have this vector. Okay. X, Y. It looks like G, but it's Y, okay, Y. Projection. You have this vector, just like before. Let's say you have flashlight, and then you will have the shadow under the ground, right? This vector is like an arrow, okay? Arrows like this. And now you are shining some light perpendicular, okay, with your flashlight. Now it has this shadow on the ground. It will be shorter than actual arrow, but yeah, it's a shadow. Now, next time you have this light that goes parallel to the ground, okay, and now this is wall, ground, floor, wall, perpendicular wall. Now you have the flashlight shining this way, parallel to the ground, toward the wall. Now you have a shadow on the wall of this arrow. Okay, that's what we call projection. Okay, projection. Okay. Yeah, this is C, vector X, vector Y. Okay, C is equal to X plus Y. Vector Y, vector X, vector C. Okay, so so dot product is this. Okay. Well, let's give it some angle, okay? Theta. Cosine theta is equal to X over C. The absolute value, the length. Absolute value of a vector is length of that vector. Okay, so meaning X, which is projection onto x-axis, is equal to C times cosine theta. Okay, that's X. Y is equal to, just likewise, Y is equal to C sine theta, okay? Because what is sine theta? Y over C, okay? Theta, you know, C goes down, then Y goes up. Okay, so that's why. Yeah, all right. You following me? Yeah. Well, if not, just do some Google Bing search on trigonometry. Okay, they will explain to you better than I ever can because they are professional teachers. Or go to YouTube. Okay. Yeah, just type in like trigonometry and they will teach you for free. Okay, it's on YouTube, Wikipedia, or other websites. Yeah, knowledge is free nowadays. Okay. All right. Oh, it make me dizzy. It's too close to me. Okay, so it's time to erase again. I guess kind of refreshing because you see me very sober. This first time for everything, right? Doing this humanology or whatever when I'm totally sober. Now, where are we going with this dot product? Because in humanology we do a lot of dot products, okay? And I want to show you somewhat magical way why that product actually makes sense. So it's physical thing, right? That product, physics, mathematics, very physical. Now, we're gonna do metaphysical stuff. Mathematics, metaphysics. Physics, metaphysics. Humanology, physics, chemistry, mathematics. Humanology is metaphysical, okay? So, and actually we've done this before, briefly, in the past, several months ago, but we kind of brush it over it, okay? Because we didn't have much time. We were too busy talking about politics, which is important, okay? Politics is very important. You wanna save the world? Be a politician, okay? Yeah. And many politicians, they're good people, okay? So I have many friends who are politicians, all right? Yeah, great people, okay? So that product, okay, so it's like this. What is a dot product? You have let's say vector A, and you have vector B, and there's this angle between A and B, theta, Greek letter, okay, theta. Was A dot product B is equal to, you probably know, right? I mean, if you learn mathematics. I'm sorry if I'm boring you, but there are people who don't know mathematics and I'm teaching them, okay? So please bear it with me or fast forward, okay? No problem. It's absolute value, which is length of A times length of B times cosine theta. Okay, that's that product. If you recall, B cosine theta, what is it? It's projection. The shadow. You shine the light perpendicular from above to A, as if A is some ground like this, slanted ground, uphill. Now you wanna shine the light perpendicular to this slope. I'm bending over, like I'm bending over backward for you to teach you mathematics, okay? Maybe I can be a little bit smarter and use my right hand instead. Okay, you have this. Goodness. It's slope, okay? Uphill. Okay? Maybe it's better if I draw picture. A slope. Do you see it? Yeah. You wanna hold the flashlight so that the light beam is perpendicular to this ground. Okay. That's what we are doing here. Projection. Okay. So you vector arrow like this, the vector B, right? And this upslope is vector A. Okay. And you wanna shine the light so that it's perpendicular to this uphill A. Okay. And this vector is now the projection of B vector, which has the same direction as A, because we are projecting onto A. So this brand new vector is vector B. The length of this vector is B, absolute value, cosine theta. What's the direction? It has same direction as A. Now, okay, we're gonna. So, A has this direction, okay? So, what is a unit vector for that? Unit vector meaning it has some direction, okay, but it has length of 1, all right? So, we want to find that directional component of this vector. What is a vector? It has length and it has direction. Length, yeah, we denote it as absolute value of A. That's length, we got it. Now, how about the direction? Is this? You have vector A, right? Divide by absolute value of A. This vector has the length of 1. So it is a pure directional component of this vector A. Okay. Now, what is this brand new vector? We call it projection of B. Let's say this projection of B. Okay. It itself is a vector. Okay. Is equal to what length is this? B, absolute value, cosine theta. What direction is that? Times A, vector A, divided by vector A's absolute value. Okay, so that's this vector, projection of B onto A. We have directional component here, and we have length. Okay, so voila. Whew, it's kind of complex, huh? But it's just the way it is. Okay, we cannot simplify this more than what we have here. All right, so yeah, it kind of looks simple, right? It's projection, you know, you shine the flashlight, that's easy enough. But what is this shadow of B onto A, surface A, the direction of A? Yeah, it has same direction as A. It is shorter than B. Okay, why? Because we divided this. Well, cosine itself is kind of like making it smaller. But yeah, this is just 1, right? So yeah, cosine is what makes the shadow shorter than the arrow B. Okay, so projection of B onto A is nothing but a shadow of arrow B on the surface of this A. Okay, so that's what projection is. So now, next step would be the humanological interpretation or humanological application. Or we are projecting this mathematics, right, dot product, onto the surface of humanology. Okay. The shadow of this mathematics dot product and vector algebra, we are projecting that by shining this light. We are projecting that, and now we have shadow on the surface of humanology. Application of vector algebra in humanology. Okay, it's very philosophical concept. Okay, if you don't understand now, yeah, it's okay. You can understand later. Okay, but just one step at a time. Okay, so all right, so we're not gonna erase. Okay, we just narrate. I'm gonna give you some narrative. All right. Back in the days, I mean, several months ago, we said there's two people. Okay, yeah, I'm anti-gayist. Also, I'm anti-tattoo piercist, and I look at you. You're pro-gayist, and you are tattoo piercist. Okay, you have tattoos, you have piercings, and you have you subscribe to gayism, whatever. Okay, so my opinion about you will be something negative, right? Because we just disagree, right? So I mean, I'm not saying you are wrong. I'm saying we are different. I could be wrong. You could be right. Okay, we don't care who's right or wrong because we don't know. We are not gods. We're just human beings who disagree with each other. And I would never say I'm right and you are wrong. No, I don't know who's right or wrong. We just happen to be different. Okay, you could be right. I could be wrong. Okay, we don't know. But the fact remains we disagree. Okay, so your opinion again about me is something negative, and my opinion about you is something negative. Okay, so okay, let's write something. I don't want to erase this because maybe we should erase. Okay, because we don't want to jam this limited space because it's too distracting. It's confusing. Okay. You wanna look at this again? Just rewind. Okay, just click on that timeline. You can always go back. Right? It's recorded. It's tape recording. Okay, digital recording. Yeah. So all this brand new technology we have, like YouTube, streaming, and internet, we should take advantage of that. Okay, knowledge sharing, sharing of knowledge and ideas. We educate each other, and then it's the kingdom come, heaven come. Okay, thy will be done. Yeah, it can happen. Okay, that's what I'm doing here. All right, I want to bring the heaven and paradise on earth. Okay, we are not going to wait for Jesus. In humanology, we don't do that. No, we have to be the Jesuses. You and me. Okay, let's save the world. Let's be the second advent of Jesus. All of us has to be the second coming of the Jesus. That's the only way we can save the world. Okay, and we can do it. All right. That's why I'm running for president in 2020. All right. If I don't become president, well, that's fine. Why don't you be the president? Huh? I'll vote for you. Okay. Yeah. Caffeine in this diet soda is kicking in, and I'm kind of jittery. I don't drink coffee, but I do drink diet soda. Time to take a break yet? Let's take a break, okay? Let's take a break. Oh. Too much stuff, man. Too much. But we are tough, so we can handle it. Alright, we're back. Okay. We're back. So, do you like me? Do you like seeing me sober like this? Go ahead and elect me as your president in 2020 November, okay? Because I'm not gonna drink when I'm working. No, I drink after I'm done working. I drink at home. All right. Yeah, weekends I do drink in the morning, okay? Because when I'm the president, I'm not gonna work during the weekends. No, I will not be overworking. It'll be 40 hours a week, no more. Okay. It's not the quantity of the work; it's quality of the work. Okay, so I'll observe the Sabbath and okay, so it won't be too different. Yeah, I'll be working 8 hours a day, Monday through Friday. Okay, and I won't be drinking during those work hours. No, I was just kidding when I said, oh, the only reason I want to be the president is to drink vodka all day, every day. I was joking, okay? Alright, so. Humanology, okay? So, yeah, it's like 10 o'clock on Saturday night, okay? So, look what I'm doing. I'm teaching. I'm a diligent person, okay? So, all for free, all for you. Everything I did it for you, baby. Okay, so. Alright, so. Yeah, gayism, okay? So, you have criteria vector, okay? Or issue vector. Gayism and what is it? Tattoo piercism, okay? That's the consideration, okay? We are just doing two, okay? So I'm an anti-gayist and I'm anti-tattooist because I oppose those things, okay? So let's say you are pro-gayist, you are pro-tattooist, okay? I mean, you don't have to be gay or have tattoos, but your opinion about those two issues is that you think being gay is a good thing and having tattoos is a good thing. You are pro-tattooist. You are pro-gayist. But let's assume you have no tattoos and you are not gay, okay? Meaning you are not a gayist. You are pro-gayist. You are not a tattooist. You are pro-tattooist. See the difference? Okay. Let's say you are a legislator and you are, Democratic Party, which is a great party. Yeah, liberalism. Yeah, there are many good things. Okay, Democratic Party. Yeah, there's many good people there. Okay, so, but somebody come to you and, hey, legislator, Mr. Senator, Mr. Congressman, whatever, please make a legislation, propose a legislation, non-discrimination act against gays and people with tattoos. And yeah, I think that's a great idea. So yeah, I'm gonna go to Washington D.C. tomorrow and write this law for you. You're pro-gayist and pro-tattooist, but you yourself is not gay. You don't have any tattoos. Okay, so me, I'm an anti-gayist and an anti-tattooist. Okay, so let's say you yeah, you're 100% pro-gayist. Well, maybe 9 out of 10, okay? Tattoo, yeah, well, plus 8 out of 10, okay? Me, let's say I'm very strongly against gayism and I'm very strongly against tattooism, okay? I give it negative 10, okay? So, okay, so the relationship between me and you is the dot product of these two vectors. What is this vector? Let's say opinion vector, okay? Opinion. opinion of you and opinion of I on those two issues. So what's the relationship? Is OY dot product OI, okay? And they are all vectors. Relationship is a scalar, right? Now, negative 90, negative 80, so negative 170. So you and me, we are bitter enemies. I'm conservative, you are liberal, I'm Republican, you're Democrat. Okay, so we don't see things eye to eye. We don't even look at each other. We kind of avoid eye contact. I don't want to see you. You're annoying. You don't want to see me. I'm annoying. Or whatever, right? Yeah. You got the idea, okay? So dot product is this, okay? So you have vector, right? 9 and 8, okay. It's too far away, okay? So we're gonna erase this, okay? Yeah, you can remember this, right? We're gonna actually draw a diagram here. The XY two-dimensional Cartesian coordinate. Okay, so I was like here, right? Negative 10, negative 10. You are what? Okay, let's say this gaism coordinate, and y is Pearson, right? You are at 9, comma 8. That was you. Okay. So it would look more like, not easy to draw to scale, but we're gonna exaggerate a little bit, okay? You are more like this, because 9 is longer than 8, okay? So, what is the dot product of these two vectors? It's like this, okay? Works like magic. You just extend the line here. All right? And you are making projection. This is me. Okay? This is you. This is me. I. Okay? And you look at me. Yeah, that guy is... I don't like that guy. He's opposite of me. So you are looking at me, and when you look at me, at the back of your eyeballs is my image. So there's sunlight or some lighting light, whatever, right? Light bulb light. Light comes to me and it reflects, it bounces off, and it lands on the back of your two eyeballs, image. So you see my image. Now, it's my projection onto you. That's what's happening right here. Okay? You look at me and this is the projection of me, my image, in your world, your coordinate, your frame of reference, your viewpoint. And according to you, I'm such a negative figure. I'm a bigot, hater, close-minded, bullshit. That's how you see me. So, according to you, your viewpoint, I'm a very negative figure. Okay? Now, we have projection now. Okay? So, dot product, length of this, length of u times length of uh, my shadow, my image, my projection onto your world. Okay? That would be the dot product. Your vector times the projection of my vector onto your world, this times this, and yeah. Why? Because we have cosine theta, right? So and we should come up with some negative number, right? And there will be the cosine theta. Okay, so what is the theta here? It will be this. This will be the theta. It's more than 180 degree. Okay. Let's say this angle. We're gonna make up some numbers. Okay. So this angle, let's say cosine theta. Just to make the calculation easy, let's say it's 180 degree, which is pi, plus, let's say is pi over 4, okay? And cosine curve, it looks like this. That's pi, right? Then it goes like this. That's cosine function, okay? So pi plus, okay, so this is pi, 2 pi, and pi over 2, and here you have pi over 4, okay? So pi plus quarter pi, okay? Probably this is like 1 over square root 2, I think. Yeah, we did that before, right? 1 over, yeah, 1 over square root of 2, okay? So now you have pi plus a quarter pi, so it's symmetrical, okay? So, which means negative cosine pi over 4, okay? So yeah, we now have negative sign right here, okay? Actually, let's calculate that. We are just assuming we are making up some numbers, okay? We can adjust this number so that it becomes actually, you know, 5 pi over 4, this angle, okay? We are just fudging numbers, okay? So, you know what? Actually, let's do it. Okay. This should be 0, okay? Let's say you're pro-gazed, tattoo piercing, you just don't care, okay? So let's say your vector is like this. Okay, that was you, right? Okay, let's bring up third person, Z. Person Z is pro-gazed just like you are, but in terms of tattoo piercing, he just doesn't care. He's not against it or for it. So person Z, yeah, his coordinate 9, 0, okay, because he doesn't care about tattoos, piercings. He's not pro, not anti. He just doesn't care. Okay, so 9, 0. All right. So now we have angle here. Let's say we don't care about you. I'm sorry, because you have difficult number here. So let's say this is theta. Okay. And then, so this person Z is kind of 9, 0. It's kind of horizontal vector, right? Now the projection of me is using different color. And this person Z, he looks at me and, I think you're still negative figure. I'm sorry. So my image in his eyes, in his brain is this. What is it? Negative 10. Okay. Meaning he's extracting this component of gayism out of me. He doesn't care. Yeah, I'm anti-tattoo purist, but he doesn't care about that. This Y component, he doesn't care. All he cares when he looks at me is that whether I'm pro-gayist or anti-gayist. I'm anti-gayist. So in his world, I'm negative 10. Okay, so let's find the dot product. Okay, so vector Z dot vector I is equal to what? 9 times me. I'm what? 10, 10, 10 times square root of 2. That's my length. Okay, I know mathematics, so that's 1 square root of 1 and then you have square root of 2 as the hypotenuse. Okay, so that's the length of my vector. Okay, so times cosine theta. What is cosine theta? Pi plus pi over 4. This, and we know negative cosine pi over 4 is equal to negative 1 over square root of 2. Okay, so is equal to minus 90. Okay, it cancels out, washes out, right? And you have negative sign. So yeah. Okay, so we got it. Okay, we got it done under 1 hour. Oh, we gotta congratulate ourselves. Okay. Ooh. Congratulations, we got it done. Okay. Oh, we're gonna erase this and should we sing and dance? Maybe. Well, I don't wanna drink, so we may call it a day. Because earlier today, right? I was doing this earlier today in the morning, and then after this, yeah, I did some dancing. Okay, watching this. I hooked up this music video, YouTube, and this computer to my big screen TV using this HDMI cable, or high definition media interface or something, HDMI. And I was drinking also, doing all this dancing, and obviously I drank a lot. So and then I got sleepy, so I went to bed, and I woke up and I went to bathroom and I threw up. Okay, so bathroom toilet was right there. Okay, in my bathroom. So yeah, no problem. I just flush it down and everything is fine. Okay, yeah, no problem. But I don't quite feel like drinking again today. It's too much drinking. So why don't I dance and do martial arts while I'm sober? You've never seen it before, me doing it, right? So let's try this. Okay, let's see if I can dance without any song, without any music, and without even being drunk. Let's do martial arts when I'm not drunk. I want to show it to you. Okay, so let's do it after a break. Alright, we'll be back. such a big challenge. My goodness. Have I ever danced? Yeah, I guess I danced sober before because when I went to dance class, yeah, I did go to back in the days, more than 10 years ago. Yeah, I went to dance classes and learned how to dance. I took some classes. Yeah, I've done it before. I was sober, of course. I mean, come on. Right, so yeah. Dancing, it takes some guts. If you have never danced before, it's a big challenge because you kind of get self-conscious. It's copium channel, okay? There are a lot of resistance. And you push copium into this channel where there's a lot of resistance, like uphill battle. It kind of negatize, it becomes pain, okay? Because your copium kind of bounces back to you, okay? Like water, you try to push water, pump water into this channel, but it's all clogged, they bounce back to you, okay? So, but drinking helps, it's kind of like lubricant, okay? Like engine oil, all right? Or music, yeah, lubricant, engine oil, okay? Kind of induces, just make it smooth, kind of smooth out this copium channel, okay? So, yeah. But dancing, once you get the hang of it, as you practice more and more, it's fun, so easy, okay? All you gotta do is express yourself, be creative, okay? I mean, that's how I do it. I mean, people do line dancing or partnership dancing, but my dancing style is more freestyle, okay? Because I wanna relax, I wanna be creative, you know? I don't wanna follow those rules and routine. Okay, so yeah, that's so easy. Okay, just spread your arm like this. Yay! Yeah. You know, snap, clap, right? Yeah. Ooh. Your neck. Yeah. Okay, you get it smooth, it's moving like right. Yeah. Woo! With your shoulder, you know. Yeah. Oh, do I feel sexy? Woo! Yeah! Yeah! Okay. Yeah, dancing, okay, so, and, oh, you can do this ticking, popping, whatever, like robot dance, right? You don't have to do this. Oh, I hate that shit. Okay, what? Why do you keep doing this? No, don't, stop doing that, okay? It's hackneyed and banal, commonplace, okay? Be creative, like robot. And you don't have to do this either. Why? Why do this? Why do this? No, stop it. Please. Yeah, popping like, you know. Okay. Yeah, you just need to stop here. Okay? So that was dancing. Oh, I'm getting hot now. Oh. Where's my water? Water is good. I love water. Alright, let's do some martial arts. Yeah. We haven't done this whip. Leather belt, of course. Whip. Okay. Now let's do this, okay? I'm not very good at it, okay? Because this is too long. Okay, yeah, you can do this, right? And some, you know, imaginary your opponent, right? Let's say there is this bear, right? You know, like this. You know, just let it roll a couple of times, right? Right? yeah, it sounds very cool. Okay. Yeah, that's pretty much it. So we did dancing, we did martial arts. I think we can call it a night, maybe. What do I do with the rest of the night then? Because I took a long nap before I went to this meeting, and I don't have much to do. I ordered a DVD movie from Amazon, and it just arrived today. So maybe I'll be watching that. It's a Chinese movie, Chinese kind of martial art, kind of old movie. It's probably made in back in 1980s. Yeah, I remember watching that movie when I was a kid, elementary schooler in Korea, South Korea. Okay. Yeah, maybe I'll just do that and just relax, sit back. Sure, yeah. It doesn't sound like a bad idea. Okay. All right. Thank you. I love you. Bye.